We learned how to write explicit formulas. Now remember, an explicit formula allows you to find any term in the sequence. It's a general formula. So it's different for arithmetic and geometric. So just a reminder, if we look at this, we can see it's arithmetic because it has a common difference. You go backwards. 4 minus 9 is negative 5. 9 minus 14 is negative 5. So everybody look, starting with 14, we're subtracting 5 each time. True? So then for arithmetic, because we're adding or subtracting, our general formula was this. You have to have it memorized for the test. A sub 1 plus n minus 1 times by the common difference. This is what the difference is. Then you would plug in everything you know. So a sub 1 is 14 plus n minus 1. Our common difference was times by negative 5. From there, you shouldn't leave it like this because on a multiple choice test, they'll take the negative 5, multiply it in. So we would have 14. And then we'll have minus 5n, and then wouldn't that be plus 5? So our general formula is a sub n is equal to negative 5n, and then 14 plus 5 is plus 19. Now if I said to you, find the 100th term, wouldn't you just plug in 100? Yeah, so that formula allows you to find that term, that term, that term, and any term. So now moving on, look at this next one. You would say, oh, this is not arithmetic because this minus this is not the same as this minus this. It's geometric. You go backwards still. This divided by this is negative 3. True? This divided by this is negative 3. This divided by this is negative 3. So starting with 1, we're timesing by negative 3 each time. So that makes it geometric. So then you'd say the explicit formula for geometric, which you need to have memorized, is a sub 1 times by r raised to the n minus 1, where r is the common ratio. This divided by this, that's what ratio means, is negative 3. So a sub n is equal to a sub 1 is 1, and then times by negative 3 raised to the n minus 1. There's the formula. If I said to you find the 100th term, you'd plug in 100, right? Okay, here's one thing to note. They're not going to write a 1 in there. It's all okay. They're not going to write it. They're going to go like this. A sub n is equal to negative 3 raised to the n minus 1. Now, don't be mistaken. That's not a sub 1. Even though there's not a 1 written there, because they won't write it, it's secretly there. Okay, everybody? Okay, sweet. Now, that's geometric. I want you to notice something. Arithmetic always has a linear equation, and geometric always has an exponential, meaning the exponent is the variable. Do you see how it's exponential? Okay. Okay, now here's another thing that we need to review. What's the difference between a sequence of numbers and a series? Perfect. Did you all hear that? This is just a sequence of numbers separated by commas that has no meaning to it. It has a pattern, but we're not doing anything with them. And this one now takes and starts adding them up, physically adding them up. Very good. Way to remember that, everybody. Okay, also, this one's arithmetic because there's a common difference. Aren't we adding 1 each time? Okay, cool. Now, what is the difference between a finite and infinite series? Good. Infinite goes to infinity. We don't know when to stop. 1, 2, 3, 4, 5. We're going to go forever, correct? Dot, dot, dot. We don't know the end. We know the start. We don't know the end. So then, yes, that goes to, also it's finite. We know the start. We know the end. So this is arithmetic. If we know the start and end, can't we find the sum? Yeah, we can actually add them up because we know when to start and stop adding. But right here, where it's going on forever and it's getting larger, or even if it was getting smaller, we would never know when to stop adding. So we could not find the sum. That's true for arithmetic. Okay, let's get to today's lesson. Oh, no. Sorry, still reviewing. Because this is basically today's lesson right here. So this is last time still. If I said to you, find the sum, we learned how to do it by writing it in summation notation and then typing it into our calculator. So let's review how to take this and write it in summation notation. So look, we have addition signs. That means find the sum. So you'd write a summation sign. Now, what goes in here? The explicit formula that generates that series. So you'd say, well, it's arithmetic. There's a common difference. Are we adding 3 each time? So now you'd say it's arithmetic, so the general formula is a sub 1 plus n minus 1 times by d. And then you'd plug in what you know. A sub 1 is 5 plus n minus 1, our common difference was 3. Then you'd take 3 and multiply it in. So then we'd have 5 plus 3n minus 3. Does everybody see? So then right here would be the simplified explicit formula, which is positive 3n, and then now it's plus 2, true? And then you'd say, well, how many terms are we summing up of that? Now look, if we plug in 1, don't we get 5? Plug in a 1, we get 5. Okay, so this is a sub 1, which makes sense. Here's a sub 2, here's a sub 3, ... Well, a sub we don't know, correct? So we need to know if this is a sub 12, then we're summing up 12 terms, true? If it's a sub 20, we're summing up 20 terms, so we don't know. We do know we're starting at 1, so at the bottom, when we write our own formula, we always put a 1, because we'll call this our first term. So we'll go n equals 1, 2, we don't know. We got to figure that out. So remember, how do we figure that out? Well, we have this formula, a sub n, any term in the sequence was this formula. 3n plus 2, isn't that true? So if this is a sub n, we just don't know what n is. We know what a sub n is. A sub n is 38. We don't know what n is. So plug in what you know. A sub n is 38. 38 equals 3. We don't know n, plus 2. Solve for n. Subtract 2. So then we would get 36 equals 3n. Divide by 3. Oh, it's 12. Does everybody see? So if this is a sub 12, so that means we're summing up 1 through 12 terms. So now you can go ahead and type that into your calculator. Everybody, remember how to do it, because I'm not going to re-go over that. So ask the people around you. So remember, the people with the advanced calculators hit math and then 0. And then you'll just type it in. Everybody else that has the non-advanced calculators, you're going to hit, just a reminder, non-advanced calculator users, you'll hit second stat, go over to math, down to sum. Then you're going to hit second stat again, and you're going to go to ops at the top, not math, but ops. And you're going to go down to sequence, the sum of a sequence. Then you put in the formula, 3n plus 2, then comma. Oh, we're going to use x on our calculator, so we're going to go 3x plus 2, comma, x, comma, the lower limit is 1, the upper limit is 12. That's only for you people with the non-advanced calculators. Ready, go. What is it? 258. Okay, cool. That's the sum. Oh, so number 2, you got 96 for the people in the video who do number 2. That's fine. Good one. I just wanted to make sure you're good with the calculator. Now, here's one thing to know. Don't let this throw you off. See how they started with 4? When we write our own, we always start with 1. So if they have a 4 down here, you'll just type it into your calculator. That means they're summing up the 4th through 11th term. Doesn't matter. Your calculator will take care of all that for you. Everybody good? Okay, cool. We will never write our own with a 4. We'll always put a 1. Okay, moving on. So we're going to do the same thing with geometric series that we just did with arithmetic. So just a reminder, a geometric sequence would look like this. There's a common ratio. This divided by this is 2. This divided by this is 2. This divided by this is 2. It's a sequence because it has commas. Now right here is geometric series because now we have addition signs, but also we have a common ratio of 2. Now this would be considered finite. We know the start. We know the end. A sub 1, 2, 3, 4. Isn't this a sub 5? We know the start and end. So this would be a finite geometric series. Now here's the thing. In previous years, if I have a finite geometric series, I have taught it with this formula, which will work. However, we could just not learn that formula and instead just write it in summation notation and use our calculator. Who votes that? Yeah, I vote that too. So we're not going to learn that formula. Don't write it down. Instead, let's just write it in summation notation. Honestly, it doesn't matter. On an ACT or on any, you're going to have a calculator, so it's fine. Here we go. So I'm starting out with a really basic one to show you how it works, and then we'll do a harder one because it's not always going to be this basic. So first of all, you'd say, this says find the sum. So I'd go off to the side and say, I'm finding a sum, and we write the explicit formula here. Well, this one is not arithmetic, it's geometric. This divided by this divided by this divided by this is all 2, correct? So an explicit formula for geometric is a sub 1 times r raised to the n minus 1. So a sub 1 is 3, correct? Our r is 2, and then n minus 1. Isn't that the general formula? So that's what goes right here, just like with arithmetic. It's just arithmetic had a different formula. And then how many terms are we summing up? 1, 2, 3, 4, 5. This must be a sub 6. That means we're summing up 6 terms. So n equals 1 through 6. Type it into your calculator. Easy stuff, right? You can. Why can't you? Oh. So everybody got 189. So pretty easy stuff. Let's do another one. You should just watch this one. So everybody, is this it's finding a sum. Notice it's bouncing between positives and negatives. We're still adding these up. Obviously, it'd be easier just to add them up. I'm starting out basic to show you. So you'd say, I'm finding the sum. I got to write the explicit formula. For geometric, we know it's a sub 1, which is negative 15. And then our r, negative 2. Does everybody see how we're timesing by negative 2 each time? How could you find that? Do this divided by this divided by this divided by this. Anyways, raised to the n minus 1. So then that's what goes right here, negative 15, negative 2, n minus 1. And then how many terms are we summing up? There's a sub 1, 2, 3, 4, 5. We're doing a sub 1 through 6 again. You type it in. You get the picture. Now, I do want you to give me that sum because people were asking some really good questions once they hit enter on that. 315, it says someone? Now, people said, well, how are you getting that when you're adding up negatives? Well, look, we're adding a negative to a positive, and then aren't the positives always larger in this instance? So it makes sense that it could add up to be a positive thing, right? Your positives are bigger, so it's all good. Yeah. Okay, cool. Okay, now they're not always going to be that easy. So look right here. It's going to be more like the arithmetic ones where you're not able to just count, oh, there's 6 terms. It's going to take more work. So I would definitely write this example down real quick because you're not doing any on the homework and you will be tested on it. It's going to take more advanced algebra to solve for what term that is. Like it's going to need a logarithm, so I'd write the example down for sure. So we're not doing anything different. It says find the sum. So that means we go off to the side and do our little summation sign. We put in our general formula. So you do this divided by this and so on. It's 2. So we'd say a sub n. The general formula is a sub 1 times by r raised to the n minus 1. So a sub n is equal to a sub 1 would be 3. Our r is 2 raised to the n minus 1. No difference so far. Good point. We do not know where it ends. We do know this is, so I'm going to erase just this for a second. So we do know for a fact that here's a sub 1. True? Here's a sub 2, a sub 3, here's a sub 4, and then we have plus dot dot dot. Here's a sub, we don't know, so a sub n. Yeah, so we will, it's just the algebra comes out a little bit more advanced. We know a sub n is that, so let's put that in. 3072 is equal to 3 times 2. We don't know what n is, that's the problem. So we leave it as n minus 1. There's our true statement. I'm going to let everybody get that written down. So now from there, solving for n is where people that kind of struggle with algebra a little bit or have forgotten their rules mess up. So let's solve for n correctly. How do we get n along first step? Divide by 3. Would we take 3 in here? 6? Heck no. 3 is not raised to the n minus 1. So that divided by 3 is 1024. 1024 is equal to, now we have base 2 raised to the n minus 1. Now guess what people do? They divide by 2. You cannot get rid of a base by division. N is what we're trying to solve for. You can't divide 2 out. That's a base 2. How do you want to do base 2? Log base 2. Log base 2. So then over here we have a log base 2. So now right here, doesn't log base 2 and base 2 cancel out appropriately? So then now n minus 1 drops down, which is good. We're good there. Now right here we have log the base 2, technically, and then it eats of 1024. Now here's the thing, our calculator does not have the ability to calculate it like that, so we use the change of base formula. So remember, we can rewrite this as log of the big thing divided by log of the small thing. Now I don't mean big numbers. I mean big in size. This 2 is a mini little 2 here. Even if this was 2000 right here, it would still be the same way. It'd still be on bottom. Good point. So we can rewrite this as log of 1024 divided by log of 2. And then you'll type it into your calculator. Good, 10. So then you get 10 equals n minus 1. So then n equals 11 because you'd add 1 over. So all that work just to figure out that this is a sub 11. But does anyone need to see that? Yeah, bigger in size. Okay, cool. Sweet. And then, so now we know we're summing up that many terms. Okay, cool. Okay, now here's the thing. What if I would have said, I'm going to erase this, okay? Let's pretend I just said plus dot, dot, dot. Right now it looks infinite, doesn't it? But if I said find the sum of 10 terms, now it's finite. Don't I just put a 10 here? Okay, that's what you're going to be doing. Do 1 through 7. Oh, wait. Yeah, 1 through 7. If I said to you, is this arithmetic or geometric, what would you say? Geometric. There's a sub 1, there's r, n minus 1. Okay, you're so smart. 1 through 7, ready, go. The quicker the better, guys, so that we don't have to have homework on top of homework. If you finish 1 through 7, you will then flip over to the back and read the instructions and then do 22 through 27. Ignore that formula. You're not using it. So there's something really interesting happens and you're going to be way confused about it if you're not paying attention right now. So we talked about, so look up here. Infinite means you don't know the end. So this would be an example of something, an infinite series. Now this is arithmetic because there's a common difference of 2. You see how we're adding 2 each time. So if I said to you find the sum, you would do 1 plus 3 plus 5 plus 7 plus 9, and you would never know when to stop adding. Correct, we talked about this. So with this one, you cannot find the sum. You can't. We'd be adding forever. Now here's what is very interesting. With infinite geometric series, you actually can find the sum of some of them. And some of them you cannot. So isn't that interesting that some infinite ones, you actually can find the sum? Well, it's going to make sense in just a second. So start writing down the rules. I'll tell you the rules of when you can and can't, and then I'll make sense of it. So this is the formula for a geometric, we already know this, geometric explicit formula. So we have our a sub 1 and our r. R is what our ratio is, or what we're multiplying by each time. So we can know if you can find the sum of an infinite geometric if your r value is less than 1. Now these are just absolute value signs. So if r is negative, you just ignore the negative and just look at the positive r. And if it's less than 1, then there actually is a sum. It's called a converges to a sum. So this S stands for sum, and you would use this formula. So if it's infinite and your r is less than 1, you can find the sum and you have to use this formula because your calculator doesn't have an infinity. Like infinity is not a number, it's a place. So there's not a way to do it in your calculator. So you would use this formula. It's actually a pretty easy formula. A sub 1 and then divided by 1 minus r, and you would put that in parentheses. R is the ratio. So that keyword converges, you're going to have to know. Converges. When you converge, it's approach, like you're approaching a sum. Converging, going towards a sum. And it will make sense in just a second of why that happens. Now, less than 1 would be like, for example, a half or 2/3. Do you see what I mean? Isn't that less than 1? Okay, so now if r is greater than 1, you also only look at the positive r. If it's negative, you just ignore the negative. If it's greater than 1, like 2 or 3 or 4, for example, if it's larger than 1, if it's 1.5, it's going to not have a sum, just like with the arithmetic one. It's going to call it diverges, and you can't find the sum. And I'll explain in a second what these mean. You need to know this word. So if you can't find the sum, it's because it's diverging. So you can use those rules, and now I'm going to make sense of it. It's actually really cool, and it makes complete sense of why this works. So let me show you some examples. So we just learned this rule right here. So I'm just going to show you this first example here, and then I'll scroll back up. Okay, so looking at this, we have, I'm going to put it in context for you. Here is a geometric infinite series, right, everybody? Now look at it. If we put this into context, let's say we start with one piece of bread here. Now we're going to cut that in half each time, okay? So now we have a half a piece of bread, a half of that. Now we have a fourth of a piece of bread. Now an eighth. Now a 16th. Now a 1/3 over 32, right? You see what I'm saying? 1 over 64. Isn't that getting so small? I'm just continuing to chop this bread up. You see how I'm getting smaller and smaller? Well, eventually, I'm chopping up crumbs that can't be chopped anymore. It's like zero. Like there's nothing there to chop up anymore. So what's happening, guys, is we're starting out and we're getting smaller and smaller, and we're adding these pieces of bread together. Like so far, so good. But at a certain point, we're finally adding zero because they're so small. You see what I'm saying? Those pieces are so dang small, they're nothing. You get what I'm saying? So think about it. If you know where to stop, because you're adding zero basically, then you can find the sum. So we can figure that out. So if it's getting smaller and smaller, it's approaching zero, then you can find the sum. Now we can also use the rule. So let's see what our R is. This divided by this, this divided by this, this divided by this. That's a half. Does everybody see how R is a half? So a half is less than 1, so it converges, and we can find the sum. Our sum will be the formula, a sub 1 over 1 minus r. So what is a sub 1? 1. And then on the bottom we'll have 1 minus, our r was a half. So now you would type it into your calculator. 1 divided by, you would use parentheses, and you get 2. You literally, if you did, like by hand, if you started adding these up and kept adding, it would just get closer and closer to 2 the more you add up. And then eventually they're going to say, let's just call this 2. 1.99999999999. Let's just call it 2. It's adding up to be 2. We're adding 0. Does that make sense, everybody? Cool. So it sums up to be 2. All right, so look right here, though. 1, 2, 4, 8, 16. Isn't it getting larger and larger? Well, it's going to keep getting larger. We're not going to know when to stop adding. Do you see what I'm saying? So once again, right here, just like with arithmetic, we can't find the sum. It diverges. Now, this is how I remember diverges versus converges. Converges means it's approaching. So it approaches the sum, so let's just call it the sum. Diverges, like if you've ever heard of the movie or seen it, Divergent, it's about a group of people who can't be controlled, and then their group grows larger and larger, and they can't be controlled. So that's a stupid way to remember, but it helps me remember. Divergent is bad. You can't find the sum. Convergent, you can find the sum. What? Yes. You just like the math teachers. Okay. Yeah. Okay, does it make sense conceptually, though, why that works? Yeah. Okay, cool. Let's look at these examples. So this is exactly how I'll say it on the test. Find the sum if possible. So you would say, is it arithmetic or geometric? Well, let's see if it's geometric. So we do this divided by this divided by this. Everybody do it. Let's figure out what we're timesing by each time. You would need parentheses. Oh, you're saying we're timesing by a half each time? Oh, 1.5. Never mind, we gotta erase that one. So we're actually timesing by 1.5. Doesn't that mean we're getting larger and larger? So 1.5 is larger than 1. Starting here, we got larger and larger. Are we just going to keep getting larger? We're not going to know when to stop adding, are we? So we would say it diverges, so no sum, because it diverges. Okay. Yeah. Now let's look at this one. Do this divided by this divided by this divided by this. Negative 1/3. Now, that is our R. We're timesing by 1/3, aren't we? Don't look at the negative. Ignore the negative. Isn't 1/3 less than 1? So we started here and got smaller and smaller and smaller. So we can find the sum because eventually we're going to be adding 0 because it's so small. So you'd say the sum is equal to a sub 1 over 1 minus r since it's infinite. A sub 1 is 1/3 divided by 1 minus our r was negative 1/3. Do you see? So you do put the negative in down here just when deciding you don't look at the negative. So when you type that into your calculator, you get, everybody make sure you can type it in right, you should get 0.25 or 1/4. So if you were to take and actually start adding these up, the more you add it up, the closer and closer it would get to 0.25. And eventually you were adding 0. So hey, look at 28 on the worksheet. Find the sum if possible. So what I'm going to ask you first, is this arithmetic or geometric? Yep, because it has the form a sub 1 times r raised to the n minus 1. You'd say it's infinite. Some infinite geometric series, we can find the sum, some we can't. Don't we look at our r? Is 2/3 less than 1? Yes, so we can find the sum. It converges to a sum. It approaches a sum. So it converges to the sum of a sub 1 over 1 minus r. Plug in what you know. A sub 1, isn't that 5? Over 1 minus our r is 2/3. You would type it into your calculator using parentheses down here. What do you get? 15. Now watch how cool this is. There isn't an infinity. Infinity is not a number, it's a place. It's a really large number. We're adding up a never-ending amount of terms here. But watch how cool this is. Everybody grab your calculator and do type it in summation notation. Now instead of, you can't put in infinity because there's no such thing, but like let's put in like, I don't know, 1,000. No, let's put in something a little smaller. Like let's add up, I don't know, 500 terms. Because that's quite a bit, right? Isn't that going towards infinity in a sense? I mean, it's way far away, but so put in 500, a really large number up here. So do the sum of 1 through 500 terms of this, hit enter. Well, your calculator's going to have to think for a minute. It's adding up a lot of stuff. So the computer system is actually having to think. So give your calculator a second. Because this is getting so intense. That's what's crazy is most of the time our calculators just calculate it right away. Where this is having to sum it up, it's taking a minute. Some people's calculators are just thinking right now. So your calculator came through. Do you see how it's what your calculator did was it said it's doing this. So it said over some people's calculators can't even handle it. Wait, do you see your calculator said, okay, it's getting so dang close to 15, let's just call it 15. Does that make sense? But it worked with the formula. You need to be using the formula. I was just showing you how it really works. The formula that we just did, a sub 1 over 1 minus r. Not when you did this. I was just showing them this. You're not going to do it this way. You're going to do the formula. I was just showing you how it really does approach 15. Hey, this is the last question I have for you. I'm going to have a whole back page of the test where I just ask you this thing right here. So just look, and then I'm going to let you work. You're going to get a lot done. So watch. I'm going to say to you, given these, can you find the sum, first of all? If so, how would you do it? And then find the sum. We won't find the sums, but I just want you to say, can you find the sum? Yes or no? If so, how would you do it? So with this one, can we find the sum? Yes. Isn't this what kind? Arithmetic or geometric? Arithmetic. Well, why can't we find the sum? You know the start and end. Don't we just type it into our calculator? Yeah. Okay, cool. So you just type it into your calculator. Okay, next one. So it's 1 to infinity. It is what kind? Arithmetic or geometric? Geometric. Well, some geometrics you can. So you'd say 2 is greater than 1, so it diverges. So no sum. Does everybody see? Okay, with this one, 1 to infinity, it's infinite, it's arithmetic. Can we find the sum? Never. Nope. Arithmetic, infinite, never can find the sum. With this one, can we find the sum? Yes, it's finite. You know when to stop adding. You would just type it into your calculator, right? Calculator, I don't know. I can't talk and think at the same time. Okay, with this one, it's infinite, it's geometric. Can we find the sum? And how would we do it? S is equal to, it's 1 over 1 minus r, and then you could do it. Okay, right here, can we? This one gets people every time. Can we find the sum? No. Yes, I wanted some people to get tricked, so I'm happy. I feel fulfilled. This negative tricks people. They say negative 2 is less than 1. You don't look at the negative. So you just look at 2. 2 is greater than 1. No sum. Now think about why that works. If you're timesing by negative, if you start with 3 and times by negative 2, won't it be negative 6? Times by negative 2, that would be 12. Do you see how it's still getting larger? Right, that's why we don't look at it. Okay, focus on these problems, go. A lot of people have a hard time seeing with 3 problems that something's infinite. So everybody look at your, this is similar to the pendulum problem on your worksheet. So think about what makes something infinite? You know the start, but you don't know the end, correct? Yeah. So if you think about what a pendulum is, like basically picture me grabbing a swing, for example, even if I just use a swing, and I push it. Well, it's going to go, and then gravity is going to pull it back, and it's going to slowly get smaller and smaller till it approaches 0, true? Do you know how many swings there's going to be? No, there's really an infinite amount till it approaches 0, true? So that would be geometric infinite that is approaching 0, that converges. So look at this. A pendulum, this is not the same as yours, but very similar. A pendulum has a first swing of 100. A pendulum has a first swing of 100 centimeters. So from here to here is 100. The next swing is 99 centimeters. So the second time it only goes to here. Does everybody roughly 99 centimeters? True? So everybody, if I was to lay this out, I'd put 100 first, then 99, wouldn't I? Comma, I don't know. So let's figure out our ratio. This divided by this, isn't that how we do it? To find the R, so that'd be 0.99. So it's 99% of the original. Isn't it getting smaller and smaller and smaller? This pendulum is getting smaller and smaller and smaller until it approaches 0. So couldn't we find the total distance by adding them? So it asks for the total distance it's traveled. So we're finding the sum of a geometric, and it's infinite. So we would use the formula a sub 1 over 1 minus r. Isn't my r 0.99? 0.99 is less than 1, so we can find the sum. So a sub 1 is 100. Wasn't that the first swing? And then divided by 1 minus 0.99. And if you type that into your calculator, you get 10,000 total centimeters. So they're adding up 100 centimeters plus 99 plus whatever. Do you get what I'm saying? Okay, cool. So, finish the worksheets. The only ones you can cross out are 33 through 36. Yeah, but some people will have done those, and you're advanced thinkers. You're definitely able to do them. So, that was good practice for you. A lot of people, all my advanced thinkers got to them today. So, you're one of those people. Sorry. Everybody get this written down. We don't. How do you know there's 100 swings? If you say n is 100, so then the next one would be no, it wouldn't. It's 99. Our r is it's 99% of the original. So if you, the next swing would be take 99 and multiply it by 0.99. Don't we multiply by? You see, it's not subtracting. It's not arithmetic. Okay.